This house was built in 24 hours. How? Thanks to modern technology, APISCOR 3D printing. The walls of this house were printed entirely on site. This is the world's first actually printed house. With the advent of APISCOR technology, construction 3D printing opens a new round of evolution thanks to the innovative design of the printer. APISCOR technology consists of a mobile construction 3D printer and automatic mix and supply unit, which combine to make the construction printing process as much automated as possible and almost eliminate the human factor. This equipment is unique and has no analogs in the world today. APISCOR is compact dimensions, high printing speed, ease of transport, and maximum automation of the system. Commissioning on site takes no more than an hour. With so many advantages, the 3D printing technology easily accounted for competition with traditional methods of construction. The testing was successful and the technology is ready for mass use. Time of printing amounted to 24 hours. Soon, using new materials such as geopolymer concrete, houses could be printed in both summer and winter. In the printing process, we used horizontal fiberglass reinforcements for the walls. The quality of the printed wall surface allows to perform final finishing immediately, which significantly reduces the cost of finishing works. The roof of the printed house, in accordance with the architectural project, is flat. Such a roof can effectively withstand high snow loads and durability requirements. Its cost is comparable with steep roofs, which are common for our country. APISCOR construction 3D printing technology adapted for different methods of printed walls thermal insulation. This project used loose dry insulating material on one part of the house and polyurethane filler composition on the other. Technology does not require fixtures and fills all voids in the space between the bearing wall and the outer concrete structure, avoids the formation of cold bridges. On the inside, the printed house is no different from a regular concrete house. It is also comfortable and reliable. The house interior includes a hall, a bathroom, a living room, and a compact functional kitchen with the most modern appliances. The house size is 38 square meters. Construction costs amounted to $10,134, which corresponds to approximately $275 per square meter. And this, in view of the shape complexity of the building. Prices include all works and materials for the construction of foundation, roof, exterior and interior finishing works, installation of heat insulation of walls, windows, floors, and ceilings. A regular square house made using materials of an average price category would cost about $223 per square meter. The use of APISCOR Construction 3D printer allows to save up to 70% on erecting buildings boxes compared to traditional material and labor-intensive construction methods. The APISCOR company and its partners are confident that this house was the first step which convinced the world that 3D technology on the market today is a reality.
a world-leading robotics company with unique patented technology for fully automated end-to-end 3D printing construction. Perth-based Fast Brick Robotics is on an unwavering mission. The construction industry is an industry of custom and convention, but it's one primed for change. Industrial 3D printing is at a tipping point. It's ready to emerge from its niche status and become a viable alternative to the long-established processes in an increasing number of applications. Because the Hadrian can print the complete structure from one position, course by course, using bricks and blocks, will mean that it will compete strongly with the stand-up panel and brick veneer type buildings that are traditionally used in some areas. The high output and short return on investment of these machines could see the Hadrian X transitioning into the global marketplace. The prototype, Hadrian 105, has successfully proven that the technology delivers what it promises to do, demonstrating it can safely and accurately build a structure course by course by delivering bricks along a 30-metre boom.
So automated bricklaying really involves bringing a lot of different technologies together to solve a lot of different problems. The workflow with a traditional bricklayer is he turns up at a slab and sets out some strings and then some uprights and starts laying the bricks. He might place some door frames or window frames and they build the house wall by wall. We actually print the house layer by layer. So we do an entire course, internal walls, external walls. Laying bricks is not really the problem. The problem is dealing with the layout, where all the walls go. Because we don't need any physical constraints for setup, we don't bother placing doors or window frames. We place all of those afterwards. So the house prints up from the ground, emerging layer by layer, almost as if it's growing out of the ground.
There are so many features and benefits of the Hadrian X. This machine will build render-ready structures using precision brick and block products and modern adhesives, allowing for a much faster and more accurate brick assembly. The 3D modelling and construction allows for very fast and low-cost buildings to be completed, providing builders with efficiencies not seen in the industry before. Structures built without traditional mortar improves the thermal and acoustic quality of the building and reduces the cost of heating and cooling. Precision blocks that are ½ metre in length and the equivalent of 15 standard house bricks will allow full structures to be built in only a couple of days. The accuracy of the completed structure allows for finishing trades to move in immediately with improved speed and efficiency. Everything can be produced off-site in parallel and simply fitted. What's remarkable is that there is no limitation on how high a structure can be built in a day, because there's no sagging or collapsing under weight, and no need for cavity insulation or brick ties.
The glue application nozzles simply squirt glue onto the brick. Because we use gravity to get the glue onto the brick, we can use a wide range of construction adhesives.
The walls are completed with routed channels for wiring and plumbing, and 3D modelling allows for an accurate bill of materials for estimating, producing the lowest possible waste and further reducing cost to the consumer.